Okay, can you can see the whiteboard and you can hear me, right?
Yes.
Okay, great. Okay, so we'll be continuing with more advanced concepts. That is RDD. That is a very fundamental concept to big data, and understanding it is very important. Okay, uh, with the RDD will be used almost every line of the program, so it is very important to learn this RDD. What is RDD? So the full form of resilient. Full form is resilient distributed data set. So it is a resilient distributed data set. It will contain some data. Let's say I am reading an entire book and this book is present. Let's say the size of this book is 1 GB and this is present in 3 nodes of a 4 node cluster. So this is my cluster of computers and this book is present. Some part is present over here, some part is here, some part is here. Of course, it will be replicated, but we are not considering into place that replication factor. But for now, simple example, this books is divided into 3 parts: book 1, book 2, and book 3. That is into 3 parts, maybe around 300 MB each. So whenever I want to read this book, what I will be doing is I will be loading it into something called as a RDD. So this will be loaded into RDD or resilient distributed data set. This is a distributed thing data set because it is containing some amount of data. Okay. Whenever you see something in Spark, it consists of 3 things. One is called as a driver. The second is called as a Spark context. And the third thing is called as a RDD. So driver is nothing but a program. It is also a program, but it doesn't have any business logic. It will have start, end, and maybe error handling. That is, it defines the flow of the program. It defines the flow of the program. It doesn't have any business logic. If you come from mainframes, the JCL is kind of program. Okay. So that is a driver program which will be doing nothing but call this program, call that program, and so on, calling other programs and doing error handling and start and end. So it will be controlling the flow of the program, but it will not have any business logic. Okay. Then we studied RDD. RDD is nothing but to represent the data. It is something like variables which point to a file. It is immutable. Meaning once the data is loaded into this RDD, you cannot change the data. If you want to change the data, you will have to change and store in different RDD. So you cannot change the data in a particular RDD once loaded. That means it is called as a immutable. Even though you want to change, you have to change and store in different RDD. Okay. Spark context is used for communication between different things or different libraries to communicate with different libraries. So it consists of 3 parts. One is a driver program, one is a Spark context, and one is the RDD. RDD represents a data. It is immutable, meaning you cannot change the contents in RDD. However, you can modify the data and you can store the data in some other RDD. Okay. Let's consider an example of an RDD, how the data is there. Okay. Let's consider you are having 4 RDDs that is RDD with 4 partitions. 4 because let's say the data was present in 4 different clusters. So let's say these are the 4 partitions or the 4 places where the similar data is already stored. Okay. Let's say it is having different things like error and ID and message, warning, like let's assume it is my error file, so it can have error as well as warning. So it is having again error, ID, message. Let's say this is my 1 2 3, this is my 3. In second partition again I am having error, ID, message, info, ID, message, info, ID, message. Third one again I am having some more things like let's say info, ID, message, warning, ID, message, and warning, ID, message. So let's say this is my error file which is having different error code setup. And what is the ID for it, what is the message for it. So let's say if I want to process this particular RDD, let's say this is my data which I have loaded into RDD and I am giving the name to this RDD as let's say ERROR RDD, something like this. So this is the name of this RDD or a variable which is having this particular data, and I want to process this data. I want to apply different things, different operations on it. So what I need to do is first I need to create an RDD, let's say error RDD, and what I will do is I will load this data into this error RDD. So once I load this data from a hard disk or from a table into this error RDD, the data comes into the RAM. The data will come into RAM. So since it was 4 PCs, so the data will come into 4 RAMs at the RAM of each PC. Now what we can do is we can do two things on this data. Either we can do something called as a transformation, or we can do something called as an action. So two things are possible. One thing is called as a transformation and other thing is called as a action. Both are nothing but functions. Example of transformations are map. If you remember in the last class, we did something called as a map in Scala, map, filter, etc. So these are nothing but example of transformation. So we'll be doing this map, filter, and store the result in another RDD. We cannot store the result in same RDD because RDDs are immutable. So whenever I do any kind of transformation function like map, filter, etc., etc., the result needs to be stored in different RDD. Similarly, there can be actions such as I want a count of it, so count will be an action. I want sum of it, it will be action. I want to save it to MySQL database, it will be again an action. So what you can do is you can do transformation as well as action on an RDD. Need to note that whenever we do a transformation on RDD, it will be stored in a different RDD. You cannot store into the same RDD. Reason being, reason being cannot store into the same RDD is RDDs are mutable. Is it clear? Any doubts until now? Okay, if no doubts, we'll go further. I need the same data again, so I will just copy it. So we'll go further. Any doubts, let me know. We'll be doing this transformation and action in practical tomorrow. Okay. So I have this over here, just taken from the previous example so that I don't have to write again and again. So this is error RDD. Now what I will be doing is I need to do some filter. I need to do some filter. So filter is nothing but a type of transformation, and I only want the errors to come over here. I only want some errors to come over here. I want only errors to come over here. So it will be like over here error is only 2, error ID message. So what I'm doing is I am filtering the data and selecting only the errors. So I will get error ID message 3. This was message 1. This was error ID message. So over here we are doing a transformation wherein we are only selecting the error message. We don't need a warning or info message. Here there is nothing, so nothing will come. Here two are there, error, error, ID, message, message. So since I have filtered this, I will be storing in a different RDD. Let me give the name as error filtered RDD, something like this. So what I have done over here is I have taken the above RDD, whatever data was there from an error file, and I have filtered the data to store my data over here. Okay, so this is how it looks. But if you notice over here, if you see over here, this is a blank RDD. Data is not present, no data is present. So this is a blank RDD. So I need to do something so that I can remove this blank RDD because I don't need. So let's see how we can do that. If you're having any doubts, ask me. So I'll make it small. I've explained till now. We'll go further on this. Now what I need to do over here is I don't need the blank RDD. So since I don't need a blank RDD, what I can do is I can apply coalesce. And by doing a coalesce, what I can do is I can give the number 2. So what it means that it will put into two RDDs only. It will gather the data and put into two RDDs. Like it may combine error ID message 1, error ID message 2, message 3, and this error ID message. Over here also error ID message, error ID message, and error only 2. So these two comes over here and these three comes over here. So whatever number of new RDDs you want, if you want some specific number of new RDDs, you can apply a coalesce function, and using a coalesce you can get the two new RDDs. Let's say I give the name of this as ERRORCOLRDD. So what I have done is I have applied coalesce on it, and I said that I want two new RDDs over there, and This is how I can get it. Okay. So after that, if you want to see the result on a terminal, you can apply a new function called as a collect new action. This is a new action. These are all transformation. This collect is an action. And finally, you can see on your command line all the output. You can see the output on the command line. So you can apply a collect function and finally see the output. Any doubts until now? If any doubts, let me know. Okay. Next thing we have to note that Spark is lazy. Spark is lazy. What do I mean by lazy is even I say to the Spark to do the filter and do this, it will not do. Then after filter you will say to do coalesce, it will still not do. It will do all the work till when you ask it to give the result. So once you ask it to do the collect function, it's only then that it will execute the filter as well as coalesce. We are showing in the example, but actually whenever I do a collect function, it will do all this work, right? So what is the property of Spark? Spark is a lazy. It will not do any work like transformation, coalesce, and so on unless and until you do a collect function or unless and until you ask it what is the output of it. Is it clear? Anyone? Any doubts? Any doubts until now?
Harish, could you tell me again like about callsec? I got some issue.
With this one,
So,
coalesce.
yeah.
Okay. What coalesce does is over here, first we filtered and picked up only the errors over here. Okay. And after errors, I noticed that in the second one, I don't have any data. Over here also data is very less. So what I can do is instead of wasting the space and instead of occupying the resource of one more computer, because this is also all is happening in separate computers or separate nodes. So instead of taking a load for putting a load on each and every node, what we can do is we can put the data into just two machines and we can give the function as coalesce bracket 2. So what it will do is it will get the data into two different machines only and it will free up the resources that was unnecessarily occupied. So over here I can say coalesce n2, so the RDD will be in two partitions. Then finally to display it on a collect, we can do as a command. And then finally we said that lazy, Spark is lazy. It will not do filter, it will not do coalesce unless and until you say it to do a collect function. Okay, is it clear? Any doubts? Is it clear? Spark is a lazy, it will not do collect function unless it will not do transform, filter, and coalesce unless and until you do a collect function. Okay, so what happens is let's assume instead of doing a collect function, you are doing one more function. Let's say count. So count will do nothing but display you the output. But what is the problem over here is Spark is lazy. It does a filter and coalesce only when you do a collect. Again, it will do count. Whenever you ask him to do count, he will do again filter and coalesce. So do you notice if you are doing collect as well as count, Spark will do two times filter and coalesce. Is it clear? Because one time whenever you do call a collect, it will do filter and coalesce. Again you call a count, it will do filter and coalesce. Is it clear? So this is a problem over here that with laziness, there is one more problem that it will do if you are doing five different actions like collect count, it will do all the transformation five times, which is again will reduce the speed because same task you have to do again and again. Is it clear? So this is a problem. To solve this problem, what you can do is, to solve this problem of doing the task again and again, you can apply something called as a catching or cache or cache. Different people call it different way, cache or catch or something like this. So what you will be doing is you will be making it as a cached RDD. So whenever you will be storing into this one, you will be making it as a cached RDD, so that whenever it comes over here, the data is available. So whenever you are doing collect or count, it don't have to do the same thing again and again. If you don't make it as a cached RDD, filter and coalesce operation will happen multiple number of times. Is it clear? Any doubts until now? Anyone, any doubts? This is very important concept, cached RDD. What is cached RDD? Why the Spark is lazy? What is the problem with laziness of a Spark? Very common interview questions. What is the problem if since the Spark is lazy? How do you overcome it? And we'll be using it in programs also tomorrow. Any doubts? Let me know, or else we can go further.
Fine.
So going to transformation. Transformations, these are lazy. There are different such transformation functions like map, flat map. Each of these things we'll be seeing in a practical, so no meaning now explaining everything. Just giving you examples of few of the commonly used functions: filter, map partitions, sample, union, intersection, distinct, pipe, coalesce, group by key, reduce by key, sort by key, join, co-group. Most of the things we'll be learning when we do programming in next three classes. Basically, we'll be doing programming related to this. So it's better to learn while studying actually. So these are the commonly used transformations, and most importantly, these are lazy. They won't be done until you ask it to display the result or do some count function or you do some any action. Until some action is performed, this will be lazy. Some of the, let's go to the next one. It's not able to open the next page. I think so it has hanged. So I will start the paint. Okay, no issues. So we had seen some of the examples of transformation functions, and now we'll be seeing some of the example of actions. So actions example is reduce, collect, count, first, take, take sample, save as, save as text file, save as sequence file, and so on. So these are the different examples. We'll be studying the examples also as we do the practical.